Good evening, everybody. First of all, I apologize because I have a cold. My voice might not be the best, but I think just watching this movie, I'm going to show you that it's possible to make an hamburger without increasing our CO2 footprint. In fact, this slide shows you, I think, the most spectacular thing what happened, according to me, in science and technology over the last 50 years. We have all food, I mean, most of us, plentiful food, which is cheap, which is healthy, which is available at all times. And this is actually incredible if you consider that, in fact, in the last 50, 60 years, our population has been growing enormously. When I was born, in the late 50s already, we were actually with 2.7 billion people. Now we are with 7.8 billion people. I mean, just the scale, if you think of Brussels, is 1 million people, it's something like 5,000 cities of the size of Brussels, which have been growing in world population. Soon we will be with 8 billion people by 2024, and already settled in the current prognosis from the United Nations is that in 30 years, so the next generation, we will be with 9.8 billion people. And this number is growing extremely fast. Just look to the current numbers. This figure was taken on the 19th of February. This of course is an estimation, it's presumably an underestimation. Within the next, 3 years, we will be 200 million people and more, means a little bit less than the population of Europe, which will have to be fed again. And why is that possible? Because agriculture has improved enormously. When we look to the agricultural productivity, 1.5 centuries ago, it was very, very, very low productive. And you can see on this map, in fact, that over the years, we need less and less land to produce the same amount of food. That means that agriculture became much more efficient to produce the food that you all are using. And I come back to that several times, how this will evolve, but you can already see with the estimation that we can use technology to make food productivity even better in the coming years. Of course, this is not the case for all areas in the world. There's still many areas where at least part of the population is suffering from sufficient food supplies, and particularly in Africa, where the situation has been very bad. So you see that still something like 1 in 8 of the people on this planet have a kind of malnutrition, of even really at too little nutrition, which actually can affect their health seriously. So we're going to have something like 2 billion people more in the coming 30 years. And you can actually ask the question, is it really possible to feed all these people on this planet? And I think this question is not easy to answer, and particularly because if you look to the figures, we seem to have reached a kind of limit of productivity. This will surprise you, but the last decade, the last 10 years, the FAO, the World Agriculture Organization, showed that in 2019, and this was already the second year in this decade, that we actually need more food than what we produce. So we eat, and this planet-wide, we consume more food. Of course, we throw a lot of food away, and it's not always that efficient, and it's not well distributed over the planet. But we, as a whole of the world, we actually eat more than what we currently produce. And this is really quite a lot. If you think about it, it's something like 30 million tons of particularly cereals, wheat, corn, rice, which in fact which are more consumed than what we produced. And you can ask the question, why don't we have hunger? Why don't we see that in our shops? Well, because we have large reserves, in fact, We have for the many seeds are stored, like we have many products which are on in the shelves like everywhere, and so there's a kind of buffering like activity. Nevertheless, the question that I will try to answer this evening, are we reaching the limit of productivity? And what should we do even actually to make sure that all people on this planet are fed well in the coming 30 years and more? And this is not a simple question to answer, because the FIO estimate that in the next 30 years we have to increase the productivity by 75%. So this doesn't seem to be in proportion with the 2 billion people, but you should realize, in fact, that many areas of the world, particularly China, for example, with 1.4 billion people, they're getting more wealthy, they want to have better quality food, and not only rice, and so on, in fact, and that we need to increase the productivity. So I already showed you that population growth is a real something that worries us, and that will certainly more mouths to feed, means we have more to produce. But what maybe is the most worrying is that we're also facing, in addition to that, climate change. And climate change has an enormous impact on food productivity. Now there are some people in the world, very powerful people, which say that there is no climate change. As you all know, this is absolutely nonsense, and I'm going to actually illustrate you, I think it's for me the best illustration that climate change is real. So in the next picture, it's in fact a movie, it shows you that, shows you that in all countries of the world, what has been done here is to take the average of 30 years between the 1951 and 1980, so this 30 years period, the average yearly temperature is taken as a kind of, over this 30 years, as a kind of zero level. And what we're going to do, when the temperature is lower than this 30 years period, we show the country in blue, and when it is hotter than this 30-year average, we're going to show this in red. And this is how it looks. So you see all these countries, we start in 1980, and that is, and you see that it is, sometimes it is a little bit blue, so it's colder than the average, and nothing is happening. Then you have the World War, and then you could see maybe that there's a blink of a very cold period, and that is quite all right, nothing happens here. But then from the 80s onwards, you can actually see that the color is changing. This is 2 degrees, this dark red 2 degrees above the average temperature. So see what's happening. The world is warming. This is based upon meteorological studies in all these different countries. And I think there is no doubt about that. If you looked at that at the global level, scientists can actually measure a global temperature. This is how it looks here. And it all happens in the last 20, 30 years. Of course, because we are still continue to emit enormous amount of greenhouse gases. And in fact, we are still with more people, we produce more, and actually not sufficient is done to cope with that. Now, of course, this affects agriculture, and we can actually measure that. So I think you all remember that in the last year we had extreme high temperatures, which was really also already damaging crops. But the year before that we had a long drought period. And particularly you can see on this map, the more red it is, the more drought we had, in fact. And this affected in the whole of Europe. So in the E28 at that time affected the cereal production. So that means wheat production, barley production, so grains, in fact, with approximately 6%. So 6% less was produced again. And in fact, I found also the figures for Flanders. I don't have the figures for Brussels, there's not too much agriculture here, I think, but also not the figures of the Wallonia. But for Flanders, in fact, it turns out that the agriculture productivity was overall also 6% less. Not only looking to cereals, but it was 37% less for potatoes, 30% less for corn, and 22% less for sugar beet. If this kind of tendency, and people think is going to happen, the world is warming up, is going to happen year after year, in many areas of the world, we're seriously going to have problems with our food supplies. Now, the FAO again has done a lot of calculation on how climate change will affect our food productivity. And at the current rate of global warming, it is estimated that there will be a 25% decrease in crop yields if we don't address the climate change right now. And I think we are trying to address it at least in some countries, rich countries, but we have to realize that this has to be done at the global level, and not all countries are capable actually to do that. So this, if you look to a map here, this is in fact the percentage change in yield between 2010 and 2050. And actually you can plot, you see that the red areas, that means that there will be less produced in 2050. And you can certainly notice that Australia, the most of Africa, also South America, North America to some extent, is really going to suffer from this climate change, with even 50% reduction in productivity. Particularly in Africa, it's very worrying because in fact there the population explosion is expected to be the highest of all these different countries. You can actually see that also in the northern Europe, because you have less cold during the winter period, like now, actually going maybe today or tomorrow for the first time snow here, I cannot remember even that it never snowed in this country, but you can actually see that this is warming. But you have to realize that crop productivity in the high north is absolutely not efficient at all, because this high north is not seeing sufficient sun. So this does not compensate, in fact, for what we see here in the tropical areas of the world. So we have a serious problem. We need 75% more food by the next 30 years. It's actually nothing, in terms of time. And we are suffering the problem of climate change, which is threatening to reduce this crop productivity by 25%. Now, there's an additional problem like this on the verge, is because we have less cold winters, because we have a changing climate, we have more and more problem with diseases. Because, as you all know, in fact, many pathogens, many diseases, there's fungi and so on, they are killed, in fact, by cold temperatures. If you don't have these cold temperatures, you have reduced productivity. And you can see that here some diseases, like say 25%, in fact, of all the food that we are going to produce are affected by diseases. It's not only cold. You have now heard, I think, in the news, that this enormous locust, this is a locust. A locust, in fact, plague, which now in the Horn of Africa. This is because we had periods of a very drought period, but then we had two kind of moussons, a kind of hurricane kind of hurricanes, which brought a lot of there's a kind of humidity in the soil, and that is an extremely good place actually to reproduce this locust. These animals which make swarms, which are 100 to 200 billion in size, in fact, they eat every day the food of 80,000 people. And so this kind of catastrophes is going to happen more and more in the coming years because of this changing climate. Now, personally, and this is a kind of intermezzo on the food, plant science is going, in my opinion, to play an enormous important role in fighting the climate. And I'm going to illustrate that. Of course, climate change we have to fight on many different fronts. And we have to emit less, and it's clear and can change our way of living. But I'm going to show you that plant science can actually help. It can help with what is called climate mitigation. That means to trying to remove actually CO2 from the air. And so this can be, we can use plants to as a system, actually a very efficient system, to remove carbon dioxide, the greenhouse gas from the atmosphere. And I'm going to talk about Belgium hamburgers, which are very good for the climate, crops for protein. And of course we can also use plants to adapt to climate change. We are not going to solve the problem of climate change in the next 10 years. It's going to be taking a long effort, and it is expected that our agricultural systems will suffer from that. So we have to adapt for that. We have to make plants which are climate resilient, and which are tolerant, resistant to drought. We have to produce new, high-yielding, eco-friendly crops, sustainable agriculture. I'm going to illustrate that with a couple of examples. Let's start with the climate mitigation problem. So you all know that climate change is due to greenhouse gases. And if you just look to this one, carbon dioxide, in fact it is the most famous one, but not the only one. In fact, you see that this, since the 50s, since we see these dramatic changes in temperature on this planet, you see that the amount of carbon dioxide, in fact, is enormously increasing. This is, in fact, the retrospect is the plants are to be blamed for that. Plants which grew here 100 to 200 million years ago, which were, when there were no people here on this planet, enormous amount of plants. All these plants were finally, when finally under pressure, were converted into coal, into petrol, into gas. These fossil fuels, in fact, which we now responsible for this enormous increase in carbon dioxide. Now, I said that carbon dioxide is actually coming from plants, because indeed, I think most of you will know that plants actually use in fact carbon dioxide as their food. They are extremely efficient machines to capturing CO2 from the air, and I'm going to illustrate on that. So this picture here is from a station in Hawaii, which measures CO2 concentration in the air. So we do that in Hawaii because it's far from civilization, and so that's the best controlled, but you can actually see that since the 80s, the amount of CO2 in fact increases from year to year. But it does not increase as a straight line. It's a kind of zigzag line going up and down in fact. And you can actually ask the question, why is this kind of moving here like a zigzag? And of course, the human mankind, we add every year 37 billion ton on CO2, gigaton. We add actually to the atmosphere, in fact. And plants can capture half of it. And that explains that. So maybe that's not very clear when I say that, but if you look to a detail, so again, this same slide here, you can actually see the detail of this thing here, a couple of years, 2 years. You can see that every year it goes down, and then it goes up, and it goes down. And it goes down each time, in fact, we are experiencing the spring and the summer. Because there is more land, there are more plants, there are more trees on the Nordic hemisphere. In our spring and our summer, we can see that the CO2 concentration, that plants remove this actually CO2 and bring it back to a lower level. But we humans continue to emit enormous amounts, so it goes up again when plants dying. I mean, think about Siberia, for example. And plants, when the temperature is getting too cold, CO2 goes up, and then the next year it goes down again. So it's been calculated that when we increase the number of plants on this planet by 1.2 trillion additional trees, we can actually stop, to some extent, the further accumulation of CO2 in the atmosphere. We will not solve the problem, but at least the plants within time, when we actually have trees growing, they absorb the CO2 from the atmosphere, and we're going to stabilize the further increase for the CO2 and maybe find solutions how to use these trees in fact, to maybe do a sustainable bioeconomy. In fact, we see that worldwide, in fact, many countries start to plant trees. So we need to plant 1.2 trillion trees. This is an enormous figure. So this is the size of the whole of Australia. This is the size of the whole of India. So that we have to plant with new trees, and this of course has to be done at the global scale. So it might be possible. So there are some countries we are trying to break the world record of tree planting. I think for the Guinness Book, and last year, in fact, India was for some time was the world record holder with 66 million trees in 12 hours. And just have to repeat this 18,000 times to get to the 1.2 trillion trees. But since then, in fact, some other countries actually beat that record. Now the current record is in the hands of Ethiopia, which planted 350 million trees in less than 12 hours. So actually mobilizing the entire population. And there are fortunately many initiatives, and I really hope that also Belgium actually takes this responsibility here. But on many initiatives like these, to really as an attempt to use plants actually to capture CO2 and to actually reduce that. Of course, this forest has to remain healthy. If you have situations like in Australia a couple of months ago, in fact, where the size of the whole Benelux is again burned, you have just the opposite effect. So maybe one event that came recently in the news, because also some Belgian industrials are taking part of that, is what is called the Green Wall. You know, the Sahara is really a big problem. The Sahara is still growing, in fact, and is to make a kind of really large buffer of trees between actually this tropical forest here and the Sahara, really to try to stop the further formation of deserts in this area. This type of projects are really vital, in fact, for our society. And you will see actually that you can actually help doing that. And you can actually, the way that we use actually our food can also help to save this problem. And I will let me illustrate this. So I think, in fact, the future agriculture should be highly efficient, because that has really helped us to feed this enormous amount of people. But important, like I said, it has to be highly efficient. But we need, why? Because we need to free up space that we can use for recreating nature and to develop new forests and while maintaining our food security. We should not use this space, in fact, for building new cities. We should really make that more, we use it actually for reforestation. So, or we have to reconsider our agriculture system. So this maybe looks far-fetched, but think about it. I mean, our current farming system is actually based upon using seeds you can buy in a shop, in fact, and the farmer plants them year after year, buy new seeds and plant them again and again, so on. But this is, in fact, in terms of carbon sequestration, carbon capturing, maybe not the best thing to do. It might be possible, in fact, to develop crops like, for example, wheat, which really are perennial. I mean, they are resistant to cold, plants, in fact, which remain in the soil, and where we harvest without actually having to replant on them, which we really harvest, in fact, seeds year after year. These plants exist, for example, sugarcane, maybe one of the most productive crops in the world, particularly in Brazil, is such a plant, in fact. I mean, apple trees are, the best plant which from a CO2 perspective are actually apple trees, because they produce a lot of fruits, and they actually need very little input. So it might be possible to adopt also our agriculture system, really to make plants which are more able with this big root system, for example, more able to capture more carbon in the soil, maybe also to get less dependent on water, and maybe less dependent on nutrients which we have to give, fertilizers which we have to give to these plants to keep them actually growing. Now, agriculture is by itself, and that you presumably heard already many things about it, is actually also a producer of greenhouse gases. Not so much CO2, of course we use tractors and all these things, but that's really a small component in the whole thing. But they are producing two other greenhouse gases. One is the dinitrogen oxide, and there's actually both by using organic, so fertilizers, manure, or anorganic fertilizers, actually the same. In both manures produce as a side product this very potent greenhouse gas. But what has maybe got more your attention is this one, methane. Methane is actually emitted, particularly by animals. We use a large amount of our agriculture area for meat production. And it's quite astonishing, in fact, to see that the amount of greenhouse gases produced by animals, which particularly sheep, and by cows, by goats, by animals which are digesting grasses essentially. Well, in fact, two cows produce, both in the front and in the back, they produce the same amount of greenhouse gases as a small cow. Why is that? Because they, in that process of using plant material, in fact, this bacteria, which are responsible for that, produce methane, and methane is something like 100 times more potent as a greenhouse gas than actually CO2. So that's the reason why, in fact, there is really a strong push really to reduce, in fact, the use of meat actually in our food supplies. And we can again use the land which becomes available. We can again use this for reforestation, making again nature again. Is this possible? I mean, of course, everybody loves his hamburger. Everybody loves his beef steak. Everybody loves to eat a piece of meat. I mean, me too, my wife for sure, which is in the back here. But of course we like that. But it might be possible to actually to replace it by something which is coming from plants. And in fact, we have done the experiment in my family. My son has been buying vegetarian hamburgers for a company of friends. He didn't tell anything, and everybody liked it. And then said, "Do you like your hamburger?" Yes, they did actually. And it's because your mind, if you would have told them in advance that this would be very vegetarian, they would have not liked it at all, because it's your mind which tricks you. So this is a famous one. This is a famous hamburger, and actually the people who invented that in the US initially became very rich with it. This is called the Impossible Burger, and this hamburger is made from plants. It's actually made from soybean, and you have to do a special trick, in fact, to let it really taste. It gets a kind of fiber structure, and it tastes like an hamburger. But it's much more better for the environment, and it's actually much better for your health as well. So you do win-win situations. And we're going to see many of these things really in the future. The only problem is, in order to feed yourself, you need that this plant material needs to contain a lot of proteins. Now it is like that many of the plants which we produce, like actually in Europe, they don't contain a lot of protein. For this, what are protein containing crops? Well, the most famous is soybean, but we don't grow soybean like in Europe, at least in small areas. We import, as a European citizens, we import huge amount of soybean, particularly from North and South America. Actually, soybean, which is grown in the Amazonian forest, in fact, of course, not the forest itself, but after burning it, I mean, we are the demand of this soybean, in fact. So it's really urgent that we start to think as a society, really, how can we make protein crops for Europe? I mean, how can we improve beans? peas, and all these crops at a scale which is possible to feed a population of 500 million people in Europe. Can we do that? So this is a challenge actually. We have to develop European protein crops that can be grown in a large scale, in fact. And gradually, in fact, maybe replace at least part of the meat production that we actually have by more vegetable food, by which we can free up land that we can use for reforestation and making nature again. So I talked already a little bit about climate mitigation, but we have to adapt also to climate change. And already said we have to make climate resilient crops and high yielding eco-friendly crops again. So I already said, in my opinion, our agriculture system is going to have to be more efficient and productive. And what I'm not going to say in the next slide will be, you will not feel good about that. But it's the truth. The current society in Europe goes the other way around. We are liking organic farming, biofarming, and the problem that's this nice actually to have, but the productivity of organic farming and biofarming is just not efficient enough. We need more land. By more land that we should use for reforestation. So this is a problem. This is really a serious problem. With the current definition of organic farming, biofarming, in fact, it's not sustainable. We need more land, and that's not what we should do, in fact. And if you don't believe me, I brought you some figures. But this is a situation in France. Many of you are French-speaking, so you follow the French television. Macron is a campaign to make the whole France organic and bio. Well, this is the productivity of wheat. Here the conventional farming here in this yellow bars over the last 20 years. In green, you see the productivity of organic farming. It does not increase, it stays the same. Here, something like 2.5 times less efficient for grain productivity. The same in the US, and it's a large study here. You see here peanuts, rice, wheat, barley, soybean. For all these crops here, you see something like between 15 and 40% reduced productivity. We need more land to produce the same, and that's not what we should do again. So we have to make organic and biofarming more productive. I'm also very much in favor actually of reducing chemicals, but we have to have the toolbox actually to do that. And I will come back to that in a few minutes. So, can we improve yield? Are we not reaching the limit? Well, I think we can. For some crops, it's absolutely spectacular. And we have extremely good data from the US. You see here, this is corn. And corn here, the 40s. And then you see that actually the productivity here is it is measured in bushel per acres, but like 30, and the productivity is now something like 180, in fact. So it's almost a factor 6.5, 7 times more efficient, in fact. And this is maybe the most spectacular example, but for many other crops, it looks more or less the same. Now, are we not reaching the limit? I personally don't think that is the case. And why? What is my argument? Well, in fact, there is every year in the US a big contest, like we do the biggest pumpkin, for example, contest. They do the highest yield contest, where they use actually every farmer gets a certain amount of seeds, and they have to grow their plants on something like 0.5 hectare, and they can do whatever they want to it. At the end of the road, somebody is going to harvest what you have been growing, and the one who will produce the most of the seeds win this contest. And here you see how it, for example, in one state in Iowa, it's a very good state for growing corn. you see actually the tons per hectare. So in fact, 3 lines like here, the green line is the world average. You see the world average is going up a little bit, like in fact from 80 to 20. It's now something like 6 tons per hectare. The US average is actually higher. You can see this for only the US is going also up, and again something like 11 on the average ton per hectare. But then you see that these people who actually win the contest every year, they have an enormous productivity. They actually, even if the line goes a little bit slow, the slope of the line is a little bit better. So this is actually almost, in fact, this 50–60% more what the average in the US is doing. So it's really possible to increase yields, in fact. And there are 2 technologies that is going to be really important. Technologies that can also be made and be used to make our climate more resilient. So we have drought resistance, and we had this problem with this projector before, and so maybe I'm talking too long, like maybe my voice is trembling too much. So you can make crops which are drought resilient, we can make crops which are heat tolerant, you can make crops which are disease resistant. And this is all possible actually to do. And then our breeders actually, which develop new crops, are able to do, but it's just the pace by which these things are going is just too slow, in fact. So we need to adapt to climate change much more faster. Yeah, so there are actually 2 technologies which are going to be extremely important for future agriculture. And one is actually based upon using drones and satellites actually to do what is called precision agriculture. A land, in fact, we see it is not homogeneous. You have patches. It works perfectly well if you're standing there. Yes, you can stay here. Yeah, okay. Yeah, all right. No, just hold it. I think it's... I promise I will not talk too long anymore. Okay, so you have you see that this field is not homogeneous. In fact, it's certainly not homogeneous when they start to shake now like this. So some places in this field are full of nutrients. So there is another technology here which is called precision breeding by genome editing. This is the famous Crispr technology, and you can unplug the slides now. I will talk a little bit. Please unplug the slides. You see here drones are flying. So actually, what is now really happening already in practice, in fact, that people fly with drones over field. These drones actually monitor what's happening. For example, they can detect pathogens. When there's a disease locally, a plant starts to suffer, they can detect all this with special cameras. And then you have another drone which has a little bit of a chemical which can actually treat all this plant, and instead of spraying the whole field, you really target your chemical. And so this technology is going to be very powerful. In fact, instead of spraying the whole field, you only spray where the infection is, which can reduce the amount of chemicals really to a minimum. And the other technology is a very young technology. It was only actually discovered in fact in 2013, a very spectacular discovery, and people will get soon a Nobel Prize for that here. But it's a kind of method to advance breeding. Plant breeding is incredibly important for your food. Without that, as showed already, we increase the productivity. Well, it's because breeders actually will select crops which are doing much better. In fact, it cannot be underestimated. For example, in the case of corn, the ancestral plant is this kind of tiny seed here. It's called teosinte. It's grown in Mexico. In fact, it actually has virtually no productivity. This is your banana. In fact, your banana is a small, something like 5–6 centimeter small fruit with full of seeds actually. You can hardly eat it. And this has been developed by breeders to this modern cultivated these varieties. But also what you may be closer to home, in fact, but what you can actually see that there is, you have this chou-fleur, you have this Brussels sprout, and all these things, all these plants actually which we eat, you all know very well, they're all actually coming from this Brassica le Chiarella, and so they've just been selected actually by breeders. They're just the same plant, but with certain variation in their genetic code, which actually we can use. And that's a task of breeding to improve these crops all the time. Now, breeding is something which takes time. So we talk here about conventional breeding, and you know we have to do 2 parents in a female plant and a male plant, you cross it, and this you have to then cross again, and then you have all these plants and huge fields are growing. And in fact, is trying to select, in fact, what the breeder is doing, select these crops which are doing better and which have superior characteristics. So breeding is a slow process. It's enormous time consuming. You have to get a huge amount of plants which you have to look for. There are certain methods to improve on that. But there's something, if we have to, with the speed that the climate now is changing, I mean, it's too slow to adapt our agriculture systems. So, and even my computer is now, hello, over there? Yeah, something coming? All right, that's not very much, I would say. Like it's this is the product of conventional breeding, as you see. It takes time. That's a lot of time, and you have to be patient. It takes years and years. It takes between. I mean, actually, people tried to make potato varieties which are resistant against major fungi, phytophthorides, major disease in Belgium. Farmers have to pray 17, 18 times a year actually to do that. Otherwise, you have no potatoes in Belgium here. They're already actually breeding for resistant varieties since the 70s of last century, and still nothing works anymore now. And that, I mean, there's even a quiz in this thing. That's yes, okay, all right. Yeah, now it's time consuming, as already said 20 times. And okay, and okay, very quick and requires large investment. And I think we should also make an investment here. I think it's if I can give you drink a lot of cocktails, ladies and gentlemen. Then they need money for this new projector. Okay, so this very shaky thing here is called Crispr, and Crispr, I mean, it's very scary. Like it moves like that. But Crispr is a new technology, in fact, which is in fact allows you to do exactly the same thing as breeding, but it happens in the lab, in fact, and it's going much more faster. In fact, in breeding, we know what we want actually, which we know the genes which are responsible for a certain trait, but we have to look extremely hard to find the right combination. With CRISPR, it's targeted. It's a new technology, and it's cheap. It's fast. It doesn't use old-fashioned technology like this projector here. And what is fantastic, ladies and gentlemen, that the product of breeding, and in fact of precision breeding, like CRISPR breeding, the product is actually identical. There's nobody in this world who can make the difference between what you obtain by conventional breeding and by this new technology. And this is fantastic because we can speed up breeding enormously. So this is a test, but now it's going to shake so much that it will be very difficult for you to find the answer. So the test, this is DNA genetic code. It shakes, right? It shakes all the time. And like we have 3 billion of these letters in our genetic code, plants, like cord also like 3 billion letters. And this is a piece of the code of a wild type plant. Don't try to read it. And what we do with the conventional breeding, we're looking for variation. And I think you can spot this variation here. There is the C is different like here. And you say that that's different. That might be the difference between a choux-fleur and let's say a Brussels sprout. I mean, that's what actually makes the difference. I mean, I don't know if that is the case. It's just a theoretical example. And now I'm going to show you, and this is going to be very difficult for you. It's a test, and which makes it very difficult. Now, can you spot the difference between this one and this one? Can you? Who can spot the difference? You get a free cocktail from me. No? Okay. The answer is there is no difference. And this is because actually this has been obtained by genome editing, exactly the same. So, I mean, this is, I think, all logical for you, isn't it? But not for all people in this planet. In fact, I should say for most of the people of the planet, it's logical. In fact, this shaky map shows you that most countries in the world agree that what you obtain by classical breeding and what you obtain by this Crispr technology is identical. You cannot distinguish it from each other. And so all the green colors like here, they're all countries which have approved legislation that we can use this technology to improve agriculture. There is only one continent here, in red like here, and that is Europe, where this is not the case. This is not the case because in 2018, and that very sadly, I think, for the scientific community, and in fact for all the breeders, actually very sad for you as well, the European Court of Justice actually ruled, I think, maybe legally correct on a very old GMO legislation that genome editing crops were subject to the very strict GMO legislation. That means you cannot do almost 13, not do field trials, we cannot use it. It's actually extremely expensive to use this technology for actually improving our crops again. So this is not science-based. This is far-reaching consequences for our food security, and maybe more important, actually, also far-reaching consequences for our trade, because you cannot detect the difference. Somebody else in the world, and it's happening all the time, producing new food crops, improved crops, which have been genome editing, but you cannot detect it. There's no way that you can find it, actually. And so there's no foreign DNA inserted as with the true GMOs. And that creates a problem for world trade. So there are a huge amount of organizations. Many learned societies, academies. There's also many politicians, EU commissioners, like this. The whole farmer unions, 20 million farmers. The science advisory boards of the EU. All these shaky organizations, literally, and literally, I mean, all organizations which really rely their judgment on science, they actually protested enormously, and there is actually a movement, and we are also very much involved into that. And for example, that all major, and now it doesn't shake anymore. Wow! You see, that's the most important actually slide of all. It's amazing that you succeeded, again. But it's the most important slide, and in fact shows you that with all major plant science centers like in Europe actually tell politicians, and please change this law because this is actually really extremely important for our food security. And this is a science-based advice, and which is based upon all what we know about these systems. I said this is less important clearly this slide, but so what can be used? It's nearly finished, ladies and gentlemen, because I also get headache from this shaking all the time. But you get what can be delivered with genome editing? Much more faster than by conventional breeding. We can pathogen and pest-resistant varieties. So in eco-friendly agriculture, I mean the same goals that you have with organic and bio, less pesticide, and eco-friendly agriculture already said. You can actually improve the nutritional quality. We can make wheat, which have no gluten anymore. It was recently, just last week, a tomato variety made in Japan with this technology, which is very good for hypertension, particularly for older people. We have much more unsaturated fatty acids, which are enormous amount of health benefits. And so we have improved nutritional use efficiency, less nitrogen in the soil, because we can learn plants to use nitrogen much better, just less pollution to the environment. And we have resistance to heat and to drought, in fact, it's really going to be very important. Higher yields, less land needed to produce the same food. Protein crops, which is going to be important for replacing actually our meat production, at least to some extent. More varieties, improvement of old varieties, new crops, and so on. So I think it's really extremely important that this technology, it gets implemented as soon as possible, also in Europe, like in the rest of the world, because we think without that it will be almost impossible actually to really reach our targets in food productivity. So let me conclude with, in fact, 2 messages. Actually 3, maybe a 4th one, but that, you will see. Food production remains a major challenge. It's not, don't take it for granted that it will be with 30 years we will have sufficient food here. And it's hampered by climate change and growth of the world population. And the second thing is that science-based innovation, and I think all you believe into science, otherwise you would not be here, I think science-based innovation is the path forward to safeguard food security. And there are 2 technologies, this precision agriculture, this drone technology and so on, and this CRISPR-based precision breeding is going to be important. And most of all, people, I think the most important message, and actually it's been said by a young lady, in fact, unite behind the science. So look to the facts and don't listen to fear-mongering and people who are spreading fake news about dangers which actually are not real and not based upon facts. And this is the 4th message. I mean, listen, unite behind the science, and drink once in a while a cocktail. That's why you're here. Thank you.